Assalamu alaikum to everyone. Thank you for being here today. I'm Areeba Sahar from Chemistry Department. I'm here today to talk to you about iodine. So let us get started. Take a look on the contents which contain introduction, discovery, occurrence, sources, structure, preparation, properties, position in periodic table, isotopes, iodine and human health effects, uses, conclusion and references. So moving on to the first topic, which is introduction. Iodine is a chemical with a symbol I and atomic number 53. The heaviest of the stable halogens, it exists as a semi-lustrous non-metallic solid at standard conditions that melts to form a deep violet gas as 114 degrees Celsius and boils to violet gas at 184 degrees Celsius. Next is discovery. Iodine was first discovered by Bernard Cortius, a French chemist, in 1811, while extracting potassium and sodium and soda ash. When he accidentally added sulfuric acid, a violet-colored cloud evolved from the mass. The resulting gas was condensed into dark crystals, the first occurrence of observed solid iodine. Occurrence. Iodine is not very abundant in the Earth's crust. Its abundance is estimated to be about 0.3 to 0.5 parts per million. It ranks in the bottom third to the elements in terms of abundance. It is still more common than cadmium, silver, and gold. Its abundance in seawater is estimated to be even less, about 0.0003 parts per million. It tends to be concentrated in Earth's crust in only a few places. These places were once covered by oceans. Over millions of years, the oceans evaporated. They left behind the chemical compounds that had been dissolved in them. Today, they exist underground as salt mines. Iodine can also be collected from seawater, brackish, brine, or sea kelp. What is a sea kelp? Sea kelp is a form of seaweed. As it grows, it takes iodine out of seawater. Over time, sea kelp has a much higher concentration of iodine than seawater. Sea kelp is harvested, dried, and burned to collect iodine. The process is not much different from the one used by Cortius in 1811. Sources. Iodine is a trace element that is naturally present in some foods, is added to some types of salts, and is available as a dietary supplement. Iodine is found mainly in animal protein foods and sea vegetables, and to lesser extent in fortified foods like bread, cereals, and milk. In seaweeds, fish, shellfish, table salt labeled iodized, dairy, eggs, beef liver, chicken. Moving on to the next topic, which is the structure of iodine. It contains symbol, atomic mass, atomic number, electronic configuration, electronegatividity, melting point, and boiling point. While in the state of gas, gaseous iodine is composed of I2 molecules with an I bond, length of 266.6 picometer. The I bond is one of the longest single bonds known. It is even longer, 271.5 picometer in solid or surrounding crystalline iodine, which has the same crystal structure as chlorine and bromine. So moving on to the next topic, which is preparations of iodine. It contains three subtopics: common methods, laboratory methods, and industrial methods. Common methods of preparation of iodine. Iodine is formed by adding bromine liquid to an aqueous solution of potassium iodide or passing chlorine gas. Adding potassium iodide to copper sulfate solution also forms iodine. Iodine is formed on heating a mixture of potassium iodide, magnesium dioxide, and concentrated sulfuric acid. And here is the reaction. Moving on the laboratory methods of iodine. Iodine is prepared in the laboratory by heating a mixture of potassium iodide, MnO2, and concentrated H2SO4. Iodine is formed by heating this mixture. Iodine is a solid, but it readily converts into vapor state on heating. The vapors of iodine obtained from the above reaction are condensed at the bottom of an ice-cold cup to obtain iodine as a solid. Oxidizers like ozone hydrogen peroxides, acidic potassium permanganate, acidic potassium dichromate can also oxidize potassium iodide to iodine. Here are the examples. By the reaction of sodium hydrogen sulfate on sodium iodate. By the reaction of dilute sulfuric acid on a mixture of potassium iodate and potassium iodide, here is the reaction. By the reaction of dilute sulfuric acid on a mixture of potassium iodate and potassium iodide. Preparation of iodine by industrial method in mother liquor, mainly iodide of potassium and sodium are present in aqueous solution. Here is the reaction. Concentrated sulfuric acid is mixed in it and kept for some time, due to which the sulfur gets precipitated. MnO2 is added to the sifted liquid and heated. The impurities of the bromides of sodium and potassium also react with MnO2 and H2SO4 and form bromine. Here are the reactions. The vapors of iodine obtained from retort are cooled in aludals. Iodine is deposited as a solid on the walls of the aludals. It is separated by the Dyscopy and by sublimation it is obtained in pure state. Child saltpeter. Child saltpeter mainly contains sodium nitrate, but it also contains sodium iodate in some amount. After dissolving child in water and concentrating in aqueous solution, most of the sodium nitrate gets separated in the form of crystals. Here is a reaction. 2NaIO3 plus 5NaHSO3, 2NaHSO4 plus 2Na2SO4 plus water plus iodine. A solution of sodium bisulfite is added to the obtained solution, due to which a blue-violet precipitate of iodine is obtained. Filter this precipitate and wash it with water and dry it. This is the main method of making iodine on an industrial scale. The next is the properties of iodine. Physical and chemical properties. Physical properties of iodine are: iodine is one of the most striking and beautiful of all elements. It is crystal and also volatile. It is lustrous blue-black solid which volatilizes at room temperature into a violet blue gas with an irritating odor. When it is heated, it does not melt. Instead, it sublimes. Iodine dissolves only slightly in water, but it dissolves in many other liquids to give distinctive purple solutions. If heated under the proper conditions, it can be made to melt at 103.5 degrees Celsius and boil at 184 degrees Celsius. The density of an element is 4.98 gram per cubic centimeter. It is soluble in organic solvents such as chloroform, carbon tetrachloride, benzene, and carbon disulfide. It is also soluble in aqueous solution of potassium iodide. Aqueous solution of potassium iodide and iodine have a dark color due to the formation of Ki3. Chemical properties of iodine. Iodine combined with many elements to form iodide compound. For example, iodine on heating combined with hydrogen. It combines with other halogens to form infrahalogen compounds. For example, when chlorine is passed over solid iodine at a temperature below 0 degrees Celsius, iodine monochloride is formed. It can act as an oxidizing agent. And here are the examples. Iodine can also react with oxidizing agents to form iodic acid. It acts as a reducing agent in these reactions. And here are the examples. It gives dark blue color due to formation of starch iodide salt hybrid compound with starch solution. The blue color disappears on heating, but it regains on cooling. This reaction is used to test iodine. So moving on the next topic, position in the periodic table. Isotopes of iodine. Only one naturally occurring isotope of iodine is known, which is iodine-127. Approximately 30 radioactive isotopes of iodine have been made artificially. A number of iodine isotopes are used commercially. Moreover, iodine-123, iodine-125, and iodine-131 are commonly used. Iodine and human health. The amount of iodine in a human body is very small. Basically, iodine is very important for human health. For normal people, the amount is about equal to the size of the head of a pin. That teeny dot of the iodine can mean the difference between good and bad health. People who do not have enough can develop serious health problems. At one time, the most common of these problems was disease known as goiter. Low iodine level can cause other problems too. In most developed countries today, companies that make table salt add a small amount of potassium iodide to their salt, which is called iodized salt. People who use it get all the iodine they need for normal thyroid function, but people who living in developing countries may not be able to get iodized salt. Health effect. Iodine can have both favorable and unfavorable effects on living organisms. It tends to kill bacteria and other disease-causing organisms. In fact, this property leads to its use in sanitation system and as an antiseptic. Not so long, tincture of iodine was one of the most popular antiseptics. It was applied to wounds and cuts to prevent infection. Today, tincture of iodine has been replaced by different antiseptics. Iodine plays an important role in the health of plants and animals. In humans, it makes a group of compounds known as thyroid hormones. These chemicals are produced in the thyroid in the base of neck. These chemicals control many important bodily functions. In higher doses, iodine can irritate or burn the skin. It can also be quite poisonous if taken internally. So moving on to the next topic, here are the uses of iodine. About two-thirds of all iodine and its compounds are used in sanitation system or in making various antiseptics and drugs. Iodine is also used to make dyes, photographic films, and specialized soaps. It is used in some industries as a catalyst. It reduces the risk of some goiter. It is used in treating thyroid cancer. Iodine can be used topically in liquid form to help treat and prevent infection. It works by killing bacteria in and around mild cuts and scabs. Iodine is also used as pharmaceutical and disinfectants. Iodine is also used to make polarizing filters for LCD displays. In vertebrate biology, iodine primary function is a constituent of thyroid hormones, which is T4 and T3. It is used as a table salt and supplement to animal feed. It is also an ingredient of water purification tables that are used for drinking water preparations. Moving on to the next topic. Here is a conclusion of iodine. Basically, iodine is a mineral found in some foods. The body needs iodine to make thyroid hormones. These hormones control the body metabolism and many other important functions. The next is the references. And thank you so much for listening. Allah Hafiz.